Hey, welcome to our Security AI Plus training. Today, we're jumping right into the architectural backbone of modern AI. Look, if you really want to build and secure these incredible systems, you have to understand what's actually going on under the hood. So let's pull back that curtain and see what makes these things tick. It really comes down to this simple but super powerful idea. I mean, you wouldn't try to secure a skyscraper without looking at the blueprint first, would you? Of course not. Well, the exact same principle applies to AI. Understanding the design, the architecture, is the first and honestly the most critical step to spotting risks, putting the right controls in place, and deploying everything safely. All right, so here's our game plan. We're going to take an architect's tour of the three fundamental pillars of modern AI. First up, the versatile workhorse, deep learning. Then we'll talk about the undisputed context king, transformers. And finally, the creative rival, GANs. Then we'll wrap it all up with a really practical security guide for all you architects out there. Okay, let's start with our first pillar, deep learning. I want you to think of this as the foundational engine of pretty much all of modern AI. It's incredibly powerful, it's super versatile, and it's the technology that sits right on top of machine learning to give us the kind of advanced perception and pattern recognition we see everywhere now. So, what is this thing, really? Well, at its core, deep learning uses neural networks with tons and tons of layers. That's where the deep part comes from. Now, its real superpower is something called representation learning. You know, back in the day, engineers had to manually code systems to find specific features, like the curve of an ear in a photo. Deep learning just automates the whole thing. It learns all the important features directly from raw data, all by itself. And that right there isn't just a small step up, it's a massive, revolutionary leap. And because it's so incredibly good at finding patterns in pretty much anything, its applications are just huge. We're talking about everything from the computer vision that lets a self-driving car spot a pedestrian, all the way to the speech recognition that powers your phone's voice assistant. It's also amazing at making sense of complex data for things like fraud detection or figuring out what movie you should watch next. But of course, there's always a trade-off. Deep learning is amazingly powerful and it scales beautifully. The more data you give it, the smarter it gets. But it's also incredibly hungry for both data and computing power. Plus, the models can be what we call black boxes. That means you get the right answer, but good luck figuring out exactly how it got there. And from a security point of view, this is a huge deal. If your training data has biases or flaws, the model will not only learn them, it will amplify them, potentially leading to some really insecure outcomes. All right, moving on to our second pillar, and this is where things get really interesting. We're talking about transformers, the architecture that didn't just tweak AI, it completely changed the game on how AI understands context and the relationships within data. The big breakthrough here, which came out of a famous paper called Attention is All You Need, is this mechanism called self-attention. Okay, so imagine you read the sentence. The robot picked up the heavy box because it was strong. Self-attention is what allows the AI to instantly get that it refers to the robot, not the box. It's like it can look at an entire sequence at once and just know which words are most important to each other, no matter how far apart they are. This gives it this unbelievable grasp of context. And their impact is just everywhere. Transformers are the engine behind basically every large language model you've ever heard of. You know, the GPT-style models, BERT, T5, the whole crew. But their power isn't just for text. Vision transformers, or VITEs, use the same ideas for images, and they are absolutely essential for building the advanced multimodal systems that can process text, images, and audio all at the same time. The strengths here are total game changers. Unbelievable context awareness, and the ability to train these huge models in parallel. But wow, the challenges are just as big. They need even more data and compute than standard deep learning models, which creates a huge risk for data leakage. And trying to audit one of these giant models, it's incredibly difficult. And that brings us to our third and final pillar, generative adversarial networks, or GANs for short. Now, if transformers are the kings of understanding context, then GANs are the absolute masters of creation, and they learn in a really unique way, through competition. It's also important to note, while transformers are running the show in the world of language, GANs are right at the heart of this explosion we're seeing in visual generative AI. See, a GAN isn't just one neural network. It's actually two of them, locked in this constant contest. You've got the generator, and its only job is to create fake data. Then you have the discriminator, and its job is to spot the fakes. This adversarial cat-and-mouse game is what makes GANs so incredibly powerful. Think of it like a master art forger and a world-class detective. The forger, that's our generator, whips up a fake painting. The detective, our discriminator, studies it to see if it's real or fake. Now imagine them doing this millions of times. Eventually, the forger gets so unbelievably good that the detective can't tell the difference anymore. And at that point, the generator can create synthetic data that is just stunningly realistic. This ability to create brand new content has some mind-blowing applications, from generating photorealistic art and video to creating more data to train other AI models. But it also powers one of the single biggest security worries in AI today. Yeah, we're talking about deepfakes and all kinds of other synthetic media. So, what it all boils down to is this. GANs are brilliant at creating incredibly realistic content, often without needing perfectly labeled data. But they are notoriously unstable and really, really hard to train properly. And the potential for misuse is off the charts. From a security standpoint, you've got to be laser focused on what these things are creating. Their output is your number one concern. Okay, so we've toured the three main pillars that make up the backbone of modern AI. Now for the most important part. Let's put it all together. As an architect, as a security pro, how do you choose the right tool for the job? And more importantly, how do you lock it down? Think of this as your official cheat sheet. You'll want to use standard deep learning for those classic jobs, like classification. Turn to transformers for anything involving language, sequences, or multiple data types. And call on GANs when your goal is to generate new synthetic data. But you have got to pay super close attention to that avoid when column. Stay away from GANs if the risk of misuse is high, and think twice about transformers if you don't have rock-solid data governance. Remember, security here is definitely not one size fits all. For these really data-hungry models like deep learning and transformers, your main focus has to be on the data coming in, governance, logging everything, and constantly checking for flaws. But for GANs, the risk totally shifts to the output. You need strong controls for auditing the media they create, proving where it came from, and being super strict about who can access it. And of course, the security fundamentals always apply. No matter what architecture you're using, you absolutely need end-to-end encryption, the principle of least privilege access, comprehensive audit trails, and, for any high-stakes applications, a human in the loop. These are your absolute non-negotiables for building secure AI. And that's really the heart of it, isn't it? Knowing the architecture, that blueprint we talked about. It isn't just some boring technical detail. It's the absolute foundation for designing AI systems that are not just powerful, but also responsible and secure. So we'll end with this thought. You now have the blueprint for the backbone of modern AI. So the question is no longer just what can you build, but how are you going to build it? How will you use this knowledge to innovate while making sure that safety, security, and responsibility are baked in from the very start?
Welcome to this Security AI Plus training module. We're jumping right into a huge topic, building and actually securing AI systems. AI is everywhere, but how do we make sure it's trustworthy? That's what we're breaking down today, the absolute essentials. Okay, so let's get right to it with the one question every single security and risk professional needs to be asking themselves. When you're looking at a new AI system, where on earth do you even start to secure it?
And the answer might not be what you think. It's not about the last line of code or the data pipeline or the firewall around it. It's way more fundamental. You have to start with the blueprint, the core design that dictates every single thing it does. You start with how it learns.
So, that's what we're going to do. We're going to deconstruct that blueprint by looking at the two foundational paradigms of AI learning. These two ideas are the base for pretty much all modern AI. And look, if you don't get these, you really can't secure the system effectively. Simple as that.
First up, we've got machine learning, or ML. Probably a term you've heard 1,000 times. The easiest way to think about it? It's a pattern-finding engine. You don't give it a bunch of if-then rules. Nah, you just feed it a mountain of data, and it figures out the patterns all on its own.
Now, on the other side of the coin, you have statistical learning. And if machine learning is the engine that finds patterns, think of statistical learning as the interpreter. It's a part of ML, sure, but it's laser-focused not just on making a prediction, but on explaining the why behind it and, this is key, quantifying the uncertainty.
All right, let's dive into the first half of our blueprint and really look under the hood of this engine. Because machine learning isn't just one single thing. It's more like a family of different approaches, each with its own strengths and weaknesses. The most common one you'll run into is called supervised learning. This is exactly what it sounds like. We're the supervisor, the teacher. We give the AI tons of examples that are already labeled, like thousands of emails clearly marked phishing or benign. The model studies them until it learns how to spot the difference itself.
Then we have unsupervised learning. This is where we take the training wheels off. We give the AI a giant messy sea of unlabeled data, say all the network traffic in a company, and its job is to find the weird stuff. It has to figure out on its own what looks like a normal cluster and what's a strange outlier that just doesn't belong.
And the third number of the ML family is reinforcement learning. Honestly, the best way to think about this is like training a system by having it play a video game. It takes an action, and if it's a good one, it gets a reward, a point. If it's a bad one, it gets a penalty. Over millions of tries, it learns the best possible strategy to win the game. Okay, so why did we just walk through all that? Here's why it is absolutely crucial. Each one of these learning styles introduces its own unique risks. If your labeled data is biased, guess what? Your model will be biased. If you tell it to look for the wrong signals, attackers will exploit that. And if it overfits, meaning it just memorizes the training data, it'll be brilliant at spotting old attacks but completely blind to new ones. This tells you exactly where to focus your security efforts: the training data, the model itself, and where it makes decisions.
All right, so we've covered the engine. Now let's talk about the other half of our blueprint, the interpreter. This is the side of AI that's all about transparency, understanding, and being able to explain the why behind a decision. So, where does this interpreter really get used? Well, it's critical for any job where quantifying your uncertainty is the whole point. We're talking about things like forecasting how many security incidents you might get next quarter, building risk models you can actually defend to an auditor, or using probability to define what normal behavior looks like.
And this, right here, is the huge security advantage of the interpreter. You can defend its decisions. When a regulator comes knocking and asks why a loan was denied or a transaction was flagged, a statistical model gives you a clear, transparent answer. In highly regulated fields like finance or healthcare, that's not just a nice-to-have, it's a must-have.
So we've got the engine on one side, which is all about raw performance, and we've got the interpreter on the other, which is all about understanding and defensibility. So, how do you choose the right blueprint for the security job you're trying to do?
This table just lays out that fundamental trade-off perfectly. If your main goal is raw predictive power, say for sifting through millions of events to find threats, you're probably going to lean towards the machine learning engine. But if your goal is to justify every single decision for a risk report, well, that's a job for the statistical learning interpreter. But here's the secret. A really mature security program doesn't just pick one. It uses both, strategically. Use the right tool for the right risk. Use the interpreter where defensibility is king, and use the engine where you need massive scale. But you always use statistical methods to check the engine's work.
And that really brings us to the core message here today. Understanding this blueprint, knowing how your AI learns, is the absolute non-negotiable first step. It tells you everything. It tells you where to put your controls, how you need to test, and what your governance program has to cover to keep these incredibly powerful systems both secure and trustworthy.
So as we wrap this up, I want to leave you with this one thought. Your organization's AI is already making critical decisions right now. The real question is, do you have the blueprint? Do you really know how it learned to make those decisions? Because if you don't know how it learns, there's no way you can truly know how to secure it.